Hi there, and welcome to the activity Create a Simple Video Game on Scratch. This 4-hour activity is an introduction to coding using Scratch, an online and free coding tool with blocks designed for beginner levels in coding. This complete activity is relevant to young people between 11 and 16 years old, girls, boys, and non-binary, from middle to high school students. This activity can also be implemented in the last years of primary school with an adaptation of the activity difficulty and the level of guidance. It is better to implement this format in half classes, around 12 students, divided in groups of 2, 4 to 6 group maximum, in order to be able to interact with each group and ensure continuous follow-up and support during the activity. You will need computers or tablets with internet connection to be able to access the tool. We developed this activity with the ambition of developing both the STEM and non-technical skills of learners by fostering creativity and reflective thinking while teaching computer programming and computational thinking. Creating a game on Scratch is also more engaging than a traditional math class, which may counteract the fear many girls still have towards the subject and inspire learning to explore and enhance their STEM skills. The activity is a guided project but on the theme and artistic direction of their choice. Thus, the learners are not restricted in expressing their creativity. This project-oriented and step-by-step activity can also enhance group motivation and problem-solving skills through algorithmic thinking. We believe this activity addresses unmotivated and struggling learners through a game-based and experiential learning approach. It, in fact, borrows certain gaming principles and applies them to real-life settings to engage and enhance the motivation of the student. It encourages creativity and students to learn from their mistakes by creating their own story in game. Let's move on to the format's content, starting with an icebreaker exercise around IT history. What we encourage you to organize with your student is to warm up the session in an interactive discussion to get them excited and motivated about the upcoming activity on the computer by making them also learn more about the tool they are going to use. Just have an open discussion by asking them questions such as what is a computer, what did the first computer look like and how did it work, what is a bug and where do you think it comes from, etc. Once you have made them reflect on computers and video games, it is time to make them create their own. Step-by-step instructions in a guide attached to the format will help you create a simple video game while letting them choose their own characters. The game created in this activity is basic in terms of gameplay and is similar to already existing old-school games. We want a central character moving from left to right to avoid traps coming from the top. The aim is to survive for more than 50 seconds by dodging enemies that cause you to lose life points. You can decide on which type of elements they will have to use, like human and dinosaurs, cat and bat, rocket and stars, for example, or let them decide on their own video game logic. The activity is divided into 6 steps. The first step helps you to choose a first character, called a sprite in Scratch, and its costumes. You can determine its size, position on the screen in order to create your central character, and then define a background for the game. Then, you will create an animated version of our central actor using the costumes. After creating the animation, you will assign buttons or keys to actions so that our central actor can move from right to left, using, for example, the keyboard of the computer. You will add a new sprite that will represent the enemy or the trap that our central actor will have to avoid to keep a maximum of life points. You will give this new character a position, a size, and code its behavior, meaning falling from the top of the screen while creating multiple versions of itself to make the game more difficult. Next, you're going to add some slight more complex mathematical notions by creating variables for time with a timer and life to represent life points. And you will assign the life variable to the collision effect between sprite 1 and 2 that make lose life points. Finally, you will define a special sprite dedicated to the end of the game. Either you win the game or you lose it, depending on the conditions you add using the variables time and life. Here, when life reaches 0, it means the game is over. When your character stays alive for more than 50 seconds, it means you win the game. The game can be designed with an infinite combination of characters, colors, and backgrounds, depending on the player's tastes. You can also increase the difficulty of the game by adding other characters and objects and giving them different behaviors, like being slower, faster, bigger, or giving a bonus or a penalty, etc. Once they all have a functional game, they can of course enjoy it and play with it for some time. If all the kids were free to choose the elements of their game, they are then also encouraged to show their work to the other students and to play the other students' games, so that they are time dedicated to sharing their work and choices. At the end of the session, you can organize a feedback session to get their opinion on how they found the activity, if they found the activity easy or difficult, if they want to learn more about coding, and if yes, which type of coding activities. Regarding the feedback and the time you want to allocate to this type of activity, you have the possibility to pursue the gaming programming activity with a longer one and more complex one. Create your own adventure game that is also available in the MOOC. This complete activity will activate several skills and competencies. The students will be able to enhance their STEM skills, especially understanding the concept of algorithmics and the underlying notions such as action, instruction, sequence, loop, conditional structure, etc. Breaking down a problem into simpler subproblems, working on logic and mathematical skills. They will also enhance their digital skills by practicing the use of a computer and a coding software. Regarding literacy skills, they will have the opportunity to understand the notion of languages, natural language, computer language, as a coding system, as a communication tool, as a thinking tool, and therefore the existence and usefulness of a multiplicity of languages. Finally, they will enrich their personal, social, and learning to learn competencies as they will learn and boost their confidence by progressing step by step and with self-correction. This format has been implemented in Luxembourg successfully with 20 students, aged between 6 and 14, as well as 5 parents as part of family coding workshops. It was very positively received by the kids and also by the parents, making all of them more eager to use computers to code, not just play games, and to foster their interest in the digital fields. And now it's your turn. Create a simple video game on Scratch.